Hello everybody, I am Miss Stereo in here, and
also Mrs. Podlipsky is here, and Mr. Benjamin is not here. He's actually coaching soccer, so we had decided to run this video without him, which I think we can do that.
we can do
Stereo?
that. Okay.
Yeah.
So we are going to talk a little bit about something that you already know, that's systems in action, right? We're going to do a little bit of review of the equations. That it might be a little difficult, but with practice, I think you'll get it. Okay, so we're going to talk about force of gravity. You know that this is force of gravity. This Fg here, another word is weight. You know that, right? So that is weight. This is mass, right? And we have to multiply that times gravity. So on Earth, we have a constant that is 9.8 newtons per kilogram. You already know that.
And weight, we know, is measured in?
Weight is measured in kilograms.
No, mass is measured.
Mass is measured in kilograms. Sorry, weight is measured
in
newtons.
Yeah.
That's right. So this will be, okay, I'm just going to give you that later. Okay, so this is your main equation, sorry. This is your main equation. That's your equation 1. So I am just going to rearrange this equation. So
and why would we rearrange the equation?
because not always you are going to find Fg. This. Not always you're going to find this.
Right.
Okay?
Sometimes we want to look for mass.
Right. So if I don't know the mass in here, so I'm going to rearrange the equation and I'm going to write in here, mass equals whatever is multiplying, that is g, is going on your denominator, and Fg is your numerator. So weight is your numerator and gravity is your denominator. That will be your equation number 2. This will be your equation number 2. So this is your equation number 1, number 2. Now, still I can get another equation, Miss P. So can I do an equation number 3 for G?
So the only time you'd really need to solve G is if you weren't on Earth, I guess.
If you weren't on Earth.
Because
But
we have a constant. So if we're on
Right.
Earth, we know it's 9.8 newtons per kilo, but sometimes the questions ask you if you're on Venus or Mars or on
Right.
the moon or what have you. So
yeah.
Okay.
So where are you? Yeah, on another planet. So we are going to do now G. So G is multiplying mass. Mass is going on my denominator. Fg is going on my numerator. And these are the 3 equations, Miss P. So
Perfect.
you have one equation here, and you have the other one over here. That is 3, and this one is the number 1. Okay, so I'm going to give you an example of this. Here I have the example. It says a rock weighs 19.6 newtons on Earth. What is the mass? So,
Do you think we can get them to use grasp?
of course, you have to use that because you need to organize your information. So that's what we're going to do, okay? So I'm just going to use this, and I'm going to see what is given in here, Mrs. P.
So we know that we have a weight of 19.6.
So the weight, what is the symbol for weight?
Well, it's not W. We know
No,
that.
oh, no.
Okay. So it's actually the force of gravity.
Mrs. P, I think W is for work, isn't it?
W is for
Yeah,
work.
it's for work, okay.
So not weight.
So, yeah,
we want to
so
make sure that we don't
F-
confuse those.
Fg equals
Fg is
how much?
19.6.
And those are the units. That's
19.6
right.
newtons, yeah.
That's right. So what are we looking for is your required. What are we looking for?
Well, we're looking for the mass,
Right.
but we have one other given, but it's not given in the problem, but we already know what G is.
That's correct.
Right? So G is also given because we know we're on Earth.
That's correct. So right now you're going to see, okay, that is what I read on the problem. I read the only thing that I have on the problem is that and that. And then you're going to wondering, I think I'm missing one more thing. And then is when you know that on Earth, G is a constant and is 9.8 newtons per kilogram. Okay, you know that. So look, it's very simple, right? So you have in here now, guys, you have Fg, you have G, and you have M, right?
Right.
So now, we're going to see the solution, the analysis. Some people get a little bit confused on that. Because analysis is a big word, right? Sometimes for some people, sorry. I'm trying to erase that, and I just can't. So, okay, so analysis, in an analysis, the only thing that you have to do is you have to...
Let me help you.
Yeah, that's
there
it.
you go.
That's it.
Okay,
I got
there you
it.
go.
Sorry. In analysis, the only thing that you have to do is to write a formula.
And we just gave them another way of looking at that
Right.
formula,
So
right?
we're going to look at it. So which formula I'm going to use, Miss P?
Well, we're not going to use
this one, or this one. What
So
I'm looking for?
We're looking for mass.
Mass.
So we need to use equation number 2.
Equation number 2. Excellent. So we are going to do M equals, what was it?
M is going to be equal to F little g, so that force or the weight, over gravity divided by g. Okay?
Okay. So so I have right now, I have everything I need. Look, I have Fg, I have G, and I have M.
Because you're going to calculate
My
M.
M, my Fg, and my G.
Good.
Okay, so now I'm going to go for the solution here. Solution is plugging the numbers. Sorry, I got stuck in there. So solution, we're going to plug in the numbers. And I'm just going to go here because I don't have too much space. So M equals, so your Fg will be this value here.
Right, that's our 9.8.
9.8 newtons per kilogram. And I'm going to divide that by G, which is...
Oh, this one should, what, your Fg is actually 19.6.
That's right, thank you. Oh, that was a big mistake.
That's okay. You know what?
So 19.6
people make mistakes
newtons,
all the time,
and
so.
divided by 9.8 newtons per kilogram. As you see in here, your units, guys, your units, newtons are gone, and you are going to end up the mass in kilograms. That makes a lot of sense.
They
right?
might not be able to see because of that little
I'm
emblem in the
sorry.
corner, but we know that we plugged in the numbers, and so we are dividing 19.6 divided by 9.8.
Right.
Okay.
And then in here, on this little space that I have, sorry. So I'm just going to do this. In this space, we're going to write a paraphrase. So you have the given required analysis solution, and you have to answer with the full sentences. Also, we're going to do this division. So 19.6 divided by 9.8, that will give you 2. So that will be equals 2 kilograms.
I think, yeah, and then you just have to
Right.
put it into a sentence.
So yeah.
We're at a
you
room,
were
but they
wrong.
can do that.
So and then you answer the question. So your answer will be the mass of this rock on Earth, right, is 2 kilograms.
Perfect.
So,
So we
yeah.
were able then to rearrange the equation
Right.
and solve for mass, even though our original equation is set up to solve for weight. In this case, we can rearrange it and solve for mass.
Right. So in here, I'm just going to write a paraphrase that you're missing. Paraphrase that is... Okay, technical difficulties, but that's okay. So your paraphrase is your full sentences here, full sentence. And that's how you do it. Okay, I hope it's clear. I'm sorry, like it's just a lot of information it looks like. But when you have it straight, the rearranging the equation and the variables is easy.
That's right. So now we're going to talk about another equation, which is the work. Okay, so work, remember, is the energy required to do something, to make something perhaps move. So in this case, W, so here's our W. W is work, and work, if you recall, is in joules. Okay, so this is in joules, because it is an energy that's required to get work done, right, to do something. F is our force, so if you move a box across a desk, for example, there's going to be a force that's going to be required to actually move that. So we remember that is actually in newtons, and then our distance moved is going to be in meters. Okay,
Perfect.
so we've got our work,
Yep.
which is this one here, so that's work, our force, and our distance.
Okay, good.
So we know exactly what to do if we're looking for work. We just plug in our force and our distance, and then that's
And you
easy.
multiply that,
And you
yeah.
multiply them.
Okay.
But again, when you are looking for
Let's say, Miss P,
rearranging.
I want to look for distance. What will be the formula?
Okay, so I'm just going to move to the next slide
Good,
here.
thank
So
you.
we're going to rearrange work, and we're going to look for, actually, we're going to look for force, if that's
Yeah.
okay.
Oh, okay. No,
Okay,
that's
well,
fine.
you know what? I'll show you both, okay?
Yeah,
So if we
thank
want to
you.
rearrange this equation, we can rearrange to solve for F. So here's our first equation. Our second equation is going to be, if we're looking for f, so remember we go f is going to be equal to, and then we're going to take that d and we're going to divide both sides by d. So you end up with that in the denominator. So work divided by distance gives us our force.
The reason that you know that d is in your denominator because f is multiplying d. So wherever is multiplying f goes in the denominator.
So we're going to just flip it around, because we've got to do the opposite, right? So
Now
then
d.
our third equation that would be available is if we're looking for distance. So our distance is going to be equal to, instead of taking d and putting it on the bottom, now we're looking for d, so we're actually going to take f and put f on the bottom. So we're going to say our work divided by force is going to give us our distance.
Perfect.
So those are our two equations that we can get from our work equation, and then we're able to use either one of those.
That's good.
Okay?
That's very nice.
So I'm going to give you just a quick example. So say we have an object, and that object is going to be moved 3 meters, and we know that the work done is 100 joules. Okay? So we've got work that's been done to move that object is going to be equal to 100 joules. And we know that the object has moved 3 meters.
Okay, good.
Okay, so I'm just going to I'm going to take this here.
So what are we looking for again?
So because we might need
We're
that
looking
equation.
for what? What are we looking for?
Well, we have our work done and we have our distance, so we're actually going to be looking for force.
Okay, for force.
Okay,
Excellent.
so I'm going to take this equation here, and I'm going to move it. Where do I want to move it? Can I make it smaller? Yeah, there we go. Okay, so I'm going to move that up here just so that we know that that's there, and I'm just going to erase a few things here. Oh, something happened. I got all sorts of weird stuff happening here. That's okay.
Okay, well that's fine.
So we're going to use this equation that I've put in the corner, this one right here, to solve for force. Okay, so we've got our force is going to be equal to W over D. So when we're looking at our grasp, we have our given. So our W is equal to 100 joules.
Okay, can we write the given, required, and all that just to remind them?
Yep.
Do you
Let's
think
do
that.
that.
Will be okay?
Yep.
Yeah, it's just
Let's
to
go
remind them,
given.
right? Because it's just that's given. That's right.
Okay.
So
Given, so W is 100 joules. We've got our
and also
little
we
D,
have
3 meters.
excellent.
Okay, I'm going to put our required here.
Good. That is so useful.
It
Required.
helps us know that you know what you're talking about.
Yeah. So what are we looking for?
So we're looking for the force that's required to move that object across, okay? So force is equal to question mark. So our next one, so we've got our given, we've got our required, now we're going to have our analysis.
It's just a formula. You just write the formula on your analysis. That's all you do.
Okay,
Right?
so I'm going to do our analysis.
Yeah. Your analysis.
Okay, analysis is actually going to be that formula right there.
That's right.
Okay, so that's our formula. And then we're going
Yeah.
to do our solution.
The solution, you just plug in
You just got to
numbers.
plug it in, yeah. So
That's
we're going
it.
to say our force, which we don't know, is equal to, so we need our W.
That is
so that's
was
that one there.
100.
So it's 100 joules
Divided
by our mass, which is this one right here, which is 3 meters. So our force is 100 divided by 3, which is going to give us 33.3 repeat, but we're just going to round to 3. And then our unit is newtons.
Yes. Usually when you have kilojoules per meters or joules per meters, that's the unit says newtons.
So if we paraphrase that, we
And
know
say
that
the force of
the
force
force
applied to the
required
object or required, yeah,
to move the object
is 33.3 newtons.
is
Good job.
33.3
Yeah.
newtons.
That's all they need
Now-
to know for now.
That's it. We're just going to show you a quick way that you can sort of remember these equations. So Mrs. Terry is going to show you.
Sure.
And that's
So these are
using
the
the
triangles.
triangles.
Look, these are the triangles like this that we use sometimes. If it's good, if it's easier for you, you use it. So what does it mean? In here, look, we have FG and we have M. This line over here, that means that you're dividing. So you're dividing FG divided by M when you are looking for G. Okay? When you have M and G in the same line, you're multiplying right there. So your FG equals M times G. Times G. Do you see that? M times G. times when it's in the same line. Now, if G is not in the same line as M or G, right? So we're going to see M, this M over here equals FG, that is here, divided by G over G, right? And over here, maybe I should just do this for you to know. So that is the first one that you multiply, right? And this one is your second equation that I just did. And then I am going to do the third one, that it will be G, for this one, right? G is not in the same line as FG, so G equals FG divided by Miss M, right?
Right. Perfect.
M. So, yeah, so, oh, sorry. So this one will be your third equation right there.
Awesome.
Is that what we had before?
Isn't that nice?
Yeah.
So you can do these.
And then
with-
you do the same thing. So
Right.
this one will be times, and this one will be divided by, and divided by. That's what it means. Maybe you can rewrite it.
Sure. Yeah. So if you are looking for work, so work is this one right here. So we know that work then is going to be equal to F times D. Okay. F, force, times distance. Okay. If we are looking for force, so now we're looking for force, we know it's going to be equal to work divided by distance. And then the last one, if we are looking for distance, it's going to be equal to work divided by force.
Yeah, that's the easier way to do it, right?
I think it's nice. It gives
Yeah.
a little bit of a visual,
And
and
that's
then
it.
they know exactly what to do. So
That's it.
hopefully that helps you with your calculations. You guys should know how to do these equations moving forward. We're going to go through a couple of them tomorrow.
It's good. That was helpful.
So-
thank you. Thank you. Whoa.
Whoa.
And
Have a good night.
goodbye.